Okay, on this one we want to find the radius and interval of convergence for this given power series. First thing I'd probably do is write it in terms of its condensed form. So one way, let's see if we can figure out what the pattern is. I'm going to start this at 1, but you can start at k equals 0. If you do, your series would look a little bit different. All right. So I do know I have an alternating series, so I'm going to have a negative 1 to the k. Since I'm starting at k equals 1, that would give me a negative first term. I have only odd exponents, but it starts with 5 instead of like 3 or 1. So I'm going to take x to the 2k. If I did 2k plus 1, then this first exponent would be 3, and then it would go to 5, 7, and so on and so forth. So I'm going to do 2k plus 3, and then that's over. What do you notice about the denominators? Well, here it's an understood 1. This is 8, 27, 64, which are all perfect cubes. So this would be k cubed. Now, to find radius and interval of convergence, we use either the ratio, the root, or the geometric series test. If you can use the geometric series test, that's awesome because you don't have to check the endpoints separately. Unfortunately, this is not a geometric series. This k cubed kind of messes with that, so I'm going to go use the root test, or pardon me, the ratio test. So we're going to take the limit as k approaches infinity of the absolute value of negative 1 to the k plus 1 times x to the 2 times k plus 1 plus 3 over k plus 1 cubed times k cubed over negative 1 to the k x to the 2k plus 3. And this here, when you multiply that out, that's 2k plus 2 plus 3, which is x to the 2k plus 5. So when we do our simplification, those guys are going to cancel out and leave a negative 1 inside the absolute value. When you take the absolute value of negative 1, you get positive 1. So we will have the limit as k approaches infinity of x to the 2k plus 5 over x to the 2k plus 3 is x squared times k cubed over k plus 1 cubed. Now, since we're taking a limit as k approaches infinity, not x, I can factor the x terms out front. Remember, the only reason I've gotten rid of my absolute value is x squared is going to be always non-negative anyway, and the k's are going to positive infinity, so they're non-negative. So I have x squared times the limit as k approaches infinity of k cubed over k plus 1 cubed. So that's x squared times degree of the top is 3, degree of the bottom is 3, so we take the quotient of the leading coefficients and we get 1. So by the ratio test, we have absolute convergence when that limit is less than 1. Okay? Now, as an interval, x squared is less than 1 is going to be when negative 1 is less than x and x is less than 1. Excuse me. So we know that we have absolute convergence here. Therefore, our radius of convergence is half the length of that interval. Which is 1. Because from negative 1 to 1 is 2 units, half the distance is 1. Okay, so that's our radius of convergence. And we know that we converge between negative 1 and 1, but I don't yet know what happens at the endpoints. So we check the endpoints separately. You don't have to check the endpoints separately if it was a geometric series, because for geometric series, you know that you have divergence when the ratio is equal to 1, which would be your endpoints. So I'm going to check x equals -1 just by plugging it into our series. If we replace x with -1, we're going to have k equals 1 to infinity, -1 to the k, times -1 to the 2k plus 3 over k cubed. And if I check x equals +1, I have the series from k equals 1 to infinity of -1 to the k times 1 to the 2k plus 3 over k cubed. So that part's just a 1 for that one. Here we will have -1 to the 3k plus 3 over k cubed. And here we have the summation from k equals 1 to infinity of -1 to the k over k cubed. Now when k is 1, this is positive. When k is 2, it's negative. K is 3, it's going to be positive, and so on and so forth. So this is an alternating form of 1 over k cubed. This is also the alternating series 1 over k cubed. And so by the alternating series test, we get that both of those are convergent. Because they're, in fact, those two guys are actually absolutely convergent because it's related to the p series where p equals 3. So what that means is that if we plug in the x equals 1 or -1, we get a convergent series. So x equals 1 and -1 make our original series convergent. And so our interval of convergence would include those endpoints. So it would be from -1 to +1, inclusive.